my name's Scott Howell. I'm actually a core manager at Case Western Reserve University in Cleveland, Ohio. That's where I work. I run an optical microscopy core. So my expertise is in optical microscopy. A couple years back, I was invited by Srijit Panikkar to come up with a grant for the GIAN, and we wrote this grant a couple years back. And to tell you the truth, I sort of forgot about it for a while. It took a long time to go through, but it got approved, thankfully. So it worked out really well. And at that point then I started planning a course to come here to India. This would be my very first visit to India, to come and teach this course at the University of Kerala. And it's been a great experience for me to this point. I mean, today's our last day of the course, but I've had an absolutely wonderful time. I've learned an awful lot. As soon as I got off the plane, I was just surprised to see how many people were at the airport. It was just, I mean, in America, you don't see that amount of people, especially at 4 in the morning. So it was very, very different for me just to see the amount of people out, and the amount of people out at 4 in the morning. It was a lot of fun. I really liked it. Srijit took me to a couple Hindu temples. I had never seen anything like that before in my life. It was very cultural to see the religion, how it's practiced here in India. It was very interesting. I got to go to a family function at Srijit's also that day. So I got to see not just the academic community, but the real people of India. It was very exciting. And the one thing I've noticed since I've been here, it seems like Kerala, the people are very proud to be from Kerala. And I've noticed that in talking with the students at the course and such, that there's definitely a pride of being from this state, it seems like. Now, for the course itself, first day I gave a couple lectures. We talked about various aspects of microscopy. I've been very impressed with the students, the way they pay attention. Probably the most stunning thing to me, coming from America, is the respect I've been treated with. It has been absolutely overwhelming. The hospitality has been very genuine. I've been treated very well. It's been a great experience in that respect. I mean, in America also you're respected, but the level of respect here I've been shown has just been absolutely tremendous. I've really appreciated it. In terms of the nuts and bolts of the course, again, I've talked about microscopy, various techniques, various different things you could do with digital imaging. We've talked about live cell imaging. We've tried to cover a wide variety of topics just to expose the students to what's out there. This seems to be a very growing institution, and I can tell that things are happening here from talking to faculty and talking to other staff members that many things are happening at the University of Kerala. It is growing, it is prospering. And to see these students with their enthusiasm be excited about this growth is great. And to know I've come here for a week and been a little bit a part of it, to expose them to different techniques of microscopy, to expose them to image analysis, to expose them to these things has been great. The other nice thing I really liked about the course was this isn't just me doing a little bit of teaching. We've had some very prominent experts come from India to give individual talks also and provide their expertise, which is way beyond mine in their area of specialty. We've had some very interesting talks from Dr. Nair. Numerous other people have come and spoke here. They've talked about electron microscopy. They've talked about super resolution microscopy. I've learned a lot. I gotta admit, I came here and I thought I'd be the teacher, but also I've been the student. I've learned quite a bit during these 6 days also. I've had a great time meeting the faculty, exploring around Kerala. I got to see the Indian Ocean the other night for the first time in my life. It was very interesting. We were on the beach, and I was looking out, and I saw these lights, and I said, well, what island's that? And everybody looked at me like, what do you mean, what island's that? They go, those are fishing boats. I had never seen so many fishing boats in my life. I thought it was land. That's how many fishing boats were there. I got to go to a fish market there. It was fabulous. It was a really good time. I've had a chance to work with grad students here from Srijit's lab. They've been very nice and very accommodating to me. I've also got to experience the traffic in India, which I had heard about. I had talked to people and they said, you just have to wait till you see it. And I've seen it, and yeah, it's hard to describe. I'll go back and describe it to my relatives and such, but unless you actually see it, you don't believe it. Okay, it's different. I guess that's about all I can say. You all know what I'm talking about. It's very different than America, where it's very structured. So it's been a very good time here. I've really appreciated it. I've learned a lot. I believe the students have learned a lot. I've been treated most graciously, and it's been a very successful endeavor for me, and something I will definitely remember, I think, for the rest of my life. Okay, so first question. What do the techniques phase, contrast, and DIC have in common? B, right? They both make unstained cells easier to see. Their contrast enhancers. Remember, contrast, the ability to see like black newsprint on white paper. Okay. Okay, number 2, most important number on an objective. A, numerical aperture, right? We've talked about that ad nauseum. Okay, number 3, most important ability of a microscope objective is that it can increase. Right. Oh, that's good. You guys are doing well. Okay, 4. What is not important in live cell imaging? D, right? It's sort of a nonsense statement. Blocking is to block epitopes. It has nothing to do with GFP. It's just sort of the other three things are the important things about live cell imaging. Remember, phototoxicity, don't hurt your cells. Okay, number 5. Now this one I tried to get a little clever. A confocal makes use of what of the following? Right. The pinhole is used to block out unfocused light. The pinhole is at basically the end of the light path. Not at the beginning, at the end of the light path. It doesn't have anything to do with focusing. It has to do with when you collect the light, you get rid of the out of focus light. Okay, number 6. Bit depth refers to? C, yeah. That's probably the best answer there. The range of intensity values can be assigned to a pixel on a chip. Okay. Okay. So 7. Okay, fret is used for? Yes. Fret's the technique that we've seen here in the workshop by some of the people who came into that is what allows you to detect if they're in close contact with one another. Okay, so 8. Difference, right, Stokes shifts the difference between the excitation and the emission peaks. Okay, 9. Most important thing before designing a fluorescent microscope experiment is? You guys are good. You guys are good. Okay. 10. What's the best format to save your images? Right. It's always TIFF. TIFF's always the answer for that. JPEGs are for what? Art or PowerPoint, email, because you need that smaller size. The picture looks the same, but that's what you need them for. Okay, 11. What's the difference between a polyclonal and a monoClonal? Right, B. The polyclonal recognizes multiple epitopes. The monoclonal only recognizes the one epitope. Okay, number 12. Yep, the voxel. The pixel is 2D. The voxel is 3D. Okay, 13. Yep, D, the 2 photon, because it uses the longer wavelengths of light. They can penetrate deeper, so it work deeper. So if you have really, really thick tissue and you have to image, your first choice would be the 2 photon to try to ensure success. Okay, FRAP is a technique used to study A, exactly. Okay, 15. What techniques uses math to improve image quality? D. Okay. Okay, what do we think here? D. Deconvolution is like an algorithm that works on a stack that increases the quality. If you change the bit depth, I mean, I could see a little bit of what you're saying there. Like, more bit depth gives you more information in an image, but the real answer is D, because it really improves the image quality. Like, remember I showed this picture sort of blurry on my wide field scope, and I take it through deconvolution and improve it. So deconvolution for that, D. Okay, if you study, now I should have spelled out what ECM was. Anybody know what ECM is? Exactly, extracellular matrix, okay? Your collagens, your fibronectins, your laminins, things like that reside outside the cell. So if all you're going to do is study that with what scope? Right, TURF. TURF would be the best choice for something like that. B. Okay, 18. Antibody staining, blocking does what? Right, it keeps non-specific things from happening. That's why you block. And what do you block with? You block, if you're using a primary and secondary, you use what? Serum from the host of the secondary. Right, exactly. That's good. People have been paying attention. This is good. Okay, if your cells are not stained, then used A, phase, right? Okay, the reason to stain tissue is to C. Staining increases contrast. Like if you don't have phase contrast, all you do is bright field, you put stain on it, increase the contrast so you can see what you're looking at. 21. Good way to reduce noise. You're using laser scanning compass C. Yes, averaging. You saw that example yesterday, and it was dramatic. It was a dramatic improvement. Sure, it takes a little longer, but quite the improvement. Okay, 22. Fixation. Yes, you're like basically stopping time, gluing it all together, preserving that morphology. Okay, 23. Sort of asked the same question earlier, but 23 is C, right? Because the whole course, everything's about resolution. It's all resolution. You heard it the other day, all that math, resolution. Electron microscope, better resolution, okay? So, 24, what did I say if you're just starting a lab would be a good idea? I'd go with C, right? Except in your husband's case, it would probably be B. But yeah, C, wide field. Okay, 25. If your co-localization is 100%, then what's happened? Right, you have bleed over. Okay, you don't want that. Type of confocal here at the University of Kerala. It is B. It is a laser scanning confocal. Because remember, you see it actually zzz, 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 like sweeping. I showed that example of like somebody vacuuming. Okay, an image is really made up of A. It's sort of the physics behind it, but yeah, it's lots and lots of airy disk. Okay, 28. If you want to buy a scope that looks at plates and slides, it'd be D, the inverted. Because you could put the plate up with the cells, you could look from underneath it. Okay? Now you could look at a plate with the stereo, I'll give you that. But not really. Because if they're not stained, you're not going to see them on a stereo, probably. Okay, so the answer is D, the inverted. Okay, which of the following is not a use of fluorescence in biology? D, right? Electron microscope has nothing to do with fluorescence. Okay, if you want to look at something as big as an entire mouse size, then what kind of C? Stereo. This would be where you use the stereo. Okay, everything in terms of microscope objective is A, right? You see the questions I asked sorted twice different ways are the important ones. Okay, let's go back. Okay, 32. Changing what changes the way an image looks but not the real pixel values? It's A. It's A, scaling. That thing I was manipulating, that's scaling. It's like the axis on the graph. Remember I showed you the bar graph? You'd make the graph look silly, you make the graph look good, but the data is the data is the data is the data. The data is always the data. Okay, to determine if your antibody staining worked, you need to do what? 33. B is the best answer. B. Because you have a positive control, you have a secondary antibody control, and an autofluorescent control. I mean, D is correct a little bit. It's a good control, but it's not as good an answer as B. So in America, we always say best answer, not just the answer, best answer. I should have wrote at the top best answer. Okay. Dyes that let you look at calcium and pH are called what? Right, those are sensor dyes. And we've talked about some of this. We talked about Fura. We talked about that Frodo. Remember the Frodo, like the things get taken about a lysosome? And the pH changes the color of the dye. Okay, so 35. The thing I've harped on the whole course. What's the answer? It is B. Think before you do. Always think before you do. And You'll save yourself a world of problems. All right, good job. Any questions about the exam? Yes.
Can you show 17? What is it?
19, please. 19.
Yeah.
17. Oh. What led to the field of live cell imaging? B. Right, because if they wouldn't have discovered that, remember they got the Nobel Prize.
What is 19?
Phase contrast.
If your cells are not stained, then use A, phase contrast. Right. Right. We're good? Everybody's happy? Nobody's mad at me?